All right, for this first proof, we need to prove that the two triangles are congruent. Just a reminder, we can use SSS, SAS, ASA, AAS, and HL. So looking at this, we have to ask ourselves, what do we know, what do we have? So we are told that AD is congruent to CD. I'm going to mark that on my diagram. I'm also told that DB is perpendicular to AC, and that marking is already done for me. So at this point, there's only one other piece of information I can take from this diagram, and it's the reflexive property that DB is congruent to DB. I notice that DB is a leg for each of the triangles. AD and DC are the hypotenuses for each of the triangles, and I know that I have a right triangle in both cases. So I know that for this one I can use HL. So I'm going to go ahead and I'm going to start off with my given. We always need to write our given down because we're going to use that information in our proof. Cannot be assumed. I also like to state, when I write that given, I like to state that one of these is actually the hypotenuse, which is one of the pieces of information that I need in order to prove this. The other one allows me to say that triangle ADB and triangle CDB are right triangles. This is also another crucial piece of information because we can't use HL if we don't have right triangles. So we can say definition of right triangles for this case. All right, so I'm almost done. I just need that leg. And in looking at this, I can get the leg because of the reflexive property. And it's that one I've already marked. The DB is congruent to DB. And I can say that because of reflexive. And I'm going to mark that as the leg. So now that I have the hypotenuse, the leg, and I've stated that I have right triangles, it's acceptable to say that triangle ADB is congruent to triangle CDB by HL. All right, on number 3, we have that DB is the perpendicular bisector of AC. Now, the perpendicular marking is there for us, the right angles. But the marking that we are missing is that it is being bisected. So I'm going to go ahead and add that in. And then I notice that DB can be concluded that DB is congruent to itself by reflexive property. And I see that I would have side, angle, side for this case, for the two triangles congruent. But looking at this statement, it says prove that ADC is isosceles. In order for ADC to be isosceles, I need to know that AD and CD are congruent. So first I'm going to prove the two triangles are congruent. I need to go ahead and state my given that DB is perpendicular bisector of AC. And then I'm going to go ahead and add that DB is congruent to DB by the reflexive property. All right, I need to state that because of the information, that because DB is perpendicular to AC, then I know that angle ABD is congruent to angle CBD. And we know that because perpendicular means congruent adjacent angles. We also know from that given information, it says that AC is being bisected. So therefore I know that AB is congruent to CB, and that part is due to the definition of bisector. So now I've used all of my given information, and I notice that I have all three pieces of information that I need in here to conclude that the two triangles are congruent. And I'm going to make that conclusion by side, angle, side. So I can go ahead and say the triangle ABD is congruent to triangle CBD. Now, we needed to show that AD is congruent to DC. Well, if you notice, AD in this first triangle is the outside, or the outside two pieces, and in the second triangle, CD is the outside two pieces. Because of that, that's what we use CPCTC for. Corresponding parts, and that's what these are because they're in the same location, of congruent triangles. Well, I just proved that they're congruent, are congruent. So I can conclude that AD is congruent to CD because of CP-CTC. But I haven't actually stated the proven statement. I have not stated that triangle ADC is isosceles. So I need to state that. I need to end with that statement, and that's just simply definition of isosceles. All right, we're going to go ahead and move on to number 4. All right, so looking at this, we're going to start with our given and make our plan for our proof. AC bisects angle BAD. Well, if it bisects that angle BAD, that means that this angle here and this angle here are congruent to one another by definition of bisector. I'm also given that AB and AD are congruent, so I'm going to mark those. And I see from the picture that I can take that AC is congruent to itself. I notice that these two triangles are congruent by side, angle, side. And if the two triangles are congruent, then I know I can conclude that angles B and angles D are congruent. All right, so let's start with our given information. We have that AC bisects angle BAD. We also know that AB is congruent to AD. And I'm going to go ahead and put a little S off to the side there because that's one of my sides for my congruence statement. All right, so going on to number 2. Knowing that AC bisects angle BAD, I know that it cuts it into two congruent angles. So I know BAC is congruent to DAC. And that's simply by definition of angle bisector. Okay, well that's my angle in my SAS triangle congruent statement. So now I just need that third side. Well, the third side happens to be pretty easy to obtain in this one because it's just itself using the reflexive property. I can say that AC is congruent to AC, and that is my third side. So now that I have all 3 pieces of information in my proof, I can go ahead and say that triangle ABC is congruent to triangle. Now, order matters. You have to be careful on this. We want it to be ADC. And that's because of side, angle, side. Now, again, looking at this one, just like in the last one, we have that it goes angle A goes with angle A. They're in the same order on these two triangles. B and D are in the same order, and C are in the same order. Well, I'm supposed to prove that angle B is congruent to angle D. Since angle B and angle D are the middle letters in that congruent statement, I can go ahead and conclude that angle B is indeed congruent to angle D. And for this one, we use the CP-CTC.